Hello GCSE competing students, another video by Mr. Holmes. This one deals with algorithms and in particular we're going to talk about today the searching algorithms, and we're going to look at the linear search, how it works, and the binary search, how it works. In my next video we will take those ideas and turn them into code. What you really need to understand, however, is how these algorithms work and to be able to trace them. Right, so without further ado, let's get on to it. So searching is going to take place over either a string, a list, or 1D array, or a 2D array. Okay, it's going to be a collection of items, and all it is, it's traversing or going through. I'm going to talk about lists. It's traversing that list and locating a matching search element or an item. Now there are many versions of linear and binary searches, so the ones you may see in textbooks might be a little different, but the basic idea is the same. And for our example, that the ones I'm discussing, I'm going to assume that we're going to return the index, that is the position of where the matching item has been found, and I'm going to assume I'm going to return the first one that I have found, and then the algorithm is going to stop. Now there are variations on what you do with this, but I'm going to assume that we're going to find a matching instance and then stop, or if we don't find a matching instance, we're going to return -1 as the index item. And that makes sense because the first index item is always going to be 0, whereas -1 would not be a possible search item. That kind of tells me that I have not found what I'm looking for. Now the two main categories of searches. The first one is known as a linear search. Linear searches are brute force search algorithms. They are not very efficient, and it simply starts, they're good for unsorted lists, and so we're assuming we use this when the data is not sorted, and basically we start at the beginning of the list and we just bash our way through from beginning to end until we find a match, or we don't. The binary search, on the other hand, is far more efficient. It's very efficient, in fact. The only problem with the binary search is that we assume we already have a sorted list, and it's very efficient in that it pretty much cuts down every search. Will throw away half the list that you now will need to still be able to search. So very efficient indeed. So without further ado, let's get into looking through how a linear search would actually work. So here's my linear search. Okay, and so for the purposes of our demonstration, I'm going to assuming I have this list L, which has 7 numbers in it, arranged in random order. So the list by assumption is not sorted. Now I'm going to try and find the first occurrence of 5. So the logical way to do this is simply start at the first element and say, and the question I'm basically asking every single time is the value at position x, is L at x, L in square brackets x equal to 5. Alright, so we start off obviously with x equal to 0, because that's the first element of the list. Is L x equal to 0? The answer is no. And so we'll simply dismiss that one. So I've dismissed one element as being not equal to the number I'm looking for. I'm looking for 5, remember. Is L1 equal to 5? Answer, no, it's equal to 6. That's a no. Not found yet. Is L2 equal to 5? No, it's equal to 7. Not found. Is L3 equal to 5? No, not found. Is L4 equal to 5? No, it's a 3. I haven't found it yet. Is L5 equal to 5? Answer, yes it is. So my algorithm would stop at this point and I would return my found position at 5, which is just purely coincidental. 5 could have been anywhere in this list. But that is the linear search. You might ask what happens if you don't find what you're looking for. Well, you would just end up with more falses all the way through, and you would run out of elements, and by the time you got to the end of the list you wouldn't have found what you're looking for. The algorithm would then fail, and found position, which we started all as -1, would not change and it would stay being -1. So the linear search, brute force, start at the beginning, look at each element in turn, loop through it, and if you find it, stop. If you don't, and you run out of elements, return the not found value, whatever that may be. In our case, we're assuming that would be -1.